This video is continuing geometry vocabulary. This word is midpoint. I just spoke in the last video about bisect. Midpoint is also going to cut something in half. However, midpoint is a point that divides a segment into two congruent segments. That means you cannot have an angle midpoint. Midpoint means you have a point in the middle. So it looks just like segment bisector. If we were to look at segment bisector, coming back to here, this point right here would be considered your midpoint. A midpoint is the point in the middle of a segment. You cannot have a midpoint for an angle. So a midpoint is a point that divides a segment into two congruent segments. If you see the word midpoint, you use the word midpoint. If you see the word segment bisect, you use the words segment bisect. But if you see the word midpoint, you got to use the word midpoint. So it is a point that divides a segment into two congruent segments. Acute angle. We're going to be talking about angles now. An acute angle is an angle whose measure is less than 90 degrees. So it would look something like this. You do need to know what your degrees are. This is x degrees, would be less than 90 degrees. Anything smaller than 90 degrees. An obtuse angle is an angle whose measure is more than 90 degrees. So it would look something like this. It is an angle more than 90 degrees. A right angle is the next word. A right angle is an angle whose measure is equal to 90 degrees. Now, when we draw a right angle, to show that this is in fact a right angle, we use a box to represent that right angle, and this is our x degrees. This should be 90 degrees. A straight angle is an angle whose measure is equal to 180 degrees. So it would look like this. You actually have the entire 180 degrees. Now, as you can see, that straight angle is actually a line, and that's the important information here. A straight angle is a line. So you shouldn't say draw a straight line, because a line is already inherently straight because it's a straight angle. So if you're going to say something like that, you should say a straight angle. But if you say just draw a line, that automatically tells you that it should be straight. Vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. Now, one thing you got to know about this is that these angles are going to be congruent. Angles are congruent. Again, that means same shape and size. Now, the way this looks, they form two pairs of opposite rays. And if you remember from previously, an opposite ray is actually a line. So we're really going to have two lines intersecting. Two lines intersecting. These are opposite rays. They all four of these share this one endpoint. And so if we look at this one, this is going about northeast, and this one's going southwest. Those are opposite directions. This is an opposite ray. If we talk about this one, we have a ray going southeast, and then a ray going northwest, which are in opposite directions. So we actually have two angles that are being formed from two opposite rays. The angles that are being formed here that are congruent to each other, the vertical angles, are actually the ones that are in between the x's. So you see how this creates the letter X? That's how you know that you've created a vertical angle. You have an actual letter X. The vertical angles will be the ones that are the same size and shape. They should be across from each other. They're opposites of each other. So this angle right here is congruent to this angle right here. But you have another set as well. This angle, so I'm going to use 2 arcs for that, because I have to show the differences. 2 arcs. This angle is congruent to this angle down here. Again, I'm going to use 2 arcs. This is how we show congruency with the arcs. These are congruent to each other because they are vertical angles. They actually, if you see that they form the letter X, you have congruent angles. These 2 angles are not congruent to each other unless they are both 90 degrees. That's the only way they can be congruent to each other. But if we don't have the degrees, we cannot say that these 2 are congruent. That is impossible. Adjacent angles are 2 coplanar angles with a common side and a common vertex. So if I were to draw out an angle, one angle, and I want to draw its adjacent angle. So I'm going to have an angle. I'm going to name this angle 1. I want an adjacent angle to this one. It's 2 angles, 2 coplanar angles with a common side and a common vertex. Well, this is the vertex, so I have to have an angle that has that vertex, but it also has to share a side as well. So I can actually say that this side is where I want them to share. So I can just create another angle using this side as one of my rays, and then create another ray. And I can say this is angle 2. Now we can say that angle 1, notice I did not say measure because I'm not talking about the degree, but angle 1 and angle 2 are adjacent. I do not know the measures. I do not know if they're congruent. I do not have any marks, so I cannot say that they are bisected. I don't know any of that. I do know, however, that they share this vertex and they share this one ray, so these 2 angles are adjacent to each other. They are touching each other, they are next to each other, they are adjacent. The next word is complementary angles. Complementary angles are 2 angles whose measure sum, which means to add, to 90 degrees. Important piece, no more, no less than 2 angles. This symbol is also representing an angle. It just has an arc going through it. It means the same thing as this angle mark up here. I just put an arc through it sometimes because I don't want it to look like a less than symbol. So I have no more, no less than 2 angles. I actually have to have 2 angles that add to 90 degrees. That add to 90 degrees. Add to 90 degrees. No more, no less. These angles can be separated. They can be adjacent, but they have to add to 90 degrees, and it can only be 2 angles. That does not mean that you cannot have more angles add to 90 degrees because of the angle addition postulate. That just means if you have 3 angles and all of them add up to 90, they're not called complementary. They're just called angles that add to 90. If you have 2 angles, very specifically 2 angles, and those 2 angles add to 90 degrees, those 2 angles are considered complementary. Now, supplementary is the same thing, but it's 2 angles whose measure sum to 180 degrees. So again, this is no more, no less than 2 angles that add to 180 degrees. That means that they should form a line. Supplementary angles should form a line. But if they're separated, they can still add up to 180 degrees. Now, if you have a line a line with multiple angles coming off of it, multiple rays coming out of it, all of those angles are not considered supplementary. However, you could take two angles and add them up, and they would be considered supplementary. Linear pair. A linear pair is two angles that form a line, which also sum to 180 degrees. So linear pair are actually always going to be supplementary. So a linear pair will be supplementary. You can call them supplementary. So it's two angles that form a line. Only two angles. It's a linear pair. Linear because it's forming a line. Pair because it's only two of them. Two angles, which is why it's a pair, form a line, which is why it's called linear. So to show what this looks like, if you already have a line and you have a ray coming off of it, just one ray, I can say that this angle 1 and this angle 2 are a linear pair. Angle 1 and angle 2 are a linear pair. Now, what I was talking about earlier with regards to more angles that would come off from here, I'm just going to show a quick example. If I have a line and I have multiple rays coming off of this, say I have angle 1, angle 2, angle 3, and angle 4, all of these angles add up to 180 degrees, but we can't call all 4 of these angles supplementary. I could, however, figure out what this angle is called, and then figure out what this angle is called, and add those up to be 180 degrees, and those two would be called supplementary. Those two would be called a linear pair, the ones that are highlighted in orange. But if I just say all 4 of them add up to 180, that's because of the angle addition postulate, not because of supplementary angles. The orange highlighted ones would be considered supplementary, and they would be considered a linear pair.